In this lesson, we're going to be discussing logical operators. Our lesson objectives: learn the and, or, and not operator, and then apply the logical operator concepts to compound Boolean expressions. So logical operators are operators that interpret compound Boolean expressions and return a true or false value. What I mean by compound Boolean expressions, I mean multiple Boolean expressions, such as the one that we utilized in the last lesson, right, when we were creating those Boolean expressions using relational operators. Now we have multiple expressions like those. Now we want to combine them together and then get a single true or false value, then rather than multiple true or false value. And the return value differs given what logical operator is used and the actual Boolean expressions themselves. So let's discuss the AND operator. The AND operator is simply using the AND sign that you see here twice. And it returns true if all the expressions in the compound Boolean expression are true. If one Boolean expression is false, the entire thing is false, right? So if it sees something false, the entire thing is returned false. Whereas if both of them are true, then it returns true. So let's look at our compound Boolean expression. And by compound, we see two Boolean expressions, and we have our logical operator over here. So 4 is less than 5. 4 is less than 5. So this side will be true. 3 is less than or equal to 4. 3 is less than or equal to 4. So that is true. Both sides are true. And the entire thing is then returned true because both sides are true. All the expressions in our compound Boolean expression are true. Now let's look at this one. 6 is less than 9. 6 is in fact less than 9. So this side will be true. It will go on to the next one. 3 is greater than or equal to 4. 3 is not greater than or equal to 4. So this thing returns false. So now we're comparing true and false with our logical operator. Since we have one false statement, this entire thing becomes false. So this is the AND operator chart. So on one side, we have these values, and the other side has these values. So if a Boolean expression has true on both sides, the entire thing will be true. If one side is true and one side is false, then the entire thing is false. And similarly, if we reverse those sides, one side is false and the other one is true, then it's similarly false. And if both are false, then it's always false. So we only have one scenario where the entire thing becomes true, and that is when both sides of the AND or logical operator are true. Now we have the OR operator that utilizes these two pipe-looking things. It returns true if one of the expressions in the compound Boolean expression are true. So it's at least one expression has to be true. Even if one expression is false, as long as the other one is true, then it will return true. But if both of them are false, then it will return false. So let's look at the first scenario. 6 is less than 9. Well, 6 is less than 9, so this time will be true. Let's look at the other side. 3 is greater than or equal to 4. That is not true because 3 is not greater than or equal to 4. So this thing turns false. We have true on this side and false on this side. So the entire thing returns true because we at least have a true on this side. Whereas with the AND statement, even if we had a false statement, even if we had a true statement, if the other one was false, the entire thing would be false. But this is the logical OR operator. So as long as this is true, then the entire thing is true. Let's look at the second one. 6 is greater than 9. All right, that is a false statement. 6 is not greater than 9, so this side returns false. Then we look at the other side. 3 is greater than or equal to 4. 3 is not greater than or equal to 4, so this is false. Both sides are false. There is no true statement whatsoever within this compound Boolean expression. So the entire thing returns false. Now, just like the AND operator, I want you to make a chart for the OR operator. Alright, I hope you managed that. Let's try looking at the chart. So if we have both true values, right, we have a returned true statement because at least one of them is true, but in this case both of them are true, so it still returns true. And then if we have a true and false statement, so if one side has true and one side is false, no matter what, it will return true. It will return true if the true is on the left and the false is on the right, and vice versa. The only time we get the false scenario is when both sides are false, because there's no true statement. So if there's no true statement, then it doesn't return true in any scenario. Then we have the NOT operator. This reverses the Boolean expression. So assume that x is true and y is false. So if x is true, then this NOT operator will convert it from true to false. Now, if the y is false, and we have the NOT operator next to it, this returns true. Now, this doesn't have to be a variable. This can be a Boolean expression as well, so utilizing our relational operators. And I have a chart just like the ones that I have for AND and OR, but it's smaller, you could say. So if it's true, and we have the exclamation point, or the NOT operator specifically, then it returns false. And if it's already false, then it returns true. Basically, it makes it the opposite of what it is. So let's go onto the compiler and test out all these operators. Alrighty, so we're in the compiler, and let's try out the AND operator first. So we have Boolean x is equal to 4 is less than 5. I wrote 44 instead of 4 less than 5. And we gotta find the AND. 3 is less than or equal to 4. Now, just for the sake of simplicity, I'm going to put a parenthesis over this entire thing. So as we know from our PowerPoint, that this entire thing will return true because this statement is true, this statement is true, and since both statements have to be true with this a logical operator, then the entire thing becomes true and then gets assigned to Boolean x. And it becomes true. So let's change it up and make this, instead of less than or equal to greater than or equal to. And that becomes false, because now we have a false statement here. This is a false statement, so the entire thing becomes false, and then false gets assigned into x. Alright, so now let's use the OR operator. Now, you don't have to be simply confined to using integers only. We can use variables that represent integers and doubles as well. So let's say if I have an integer x, which is equal to maybe 6, and maybe an integer y that's equal to 9. Alright, so let me create a Boolean expression that implements these variables with integers as well, other integers as well. So x is less than 9, and then we use our logical OR operator with those two pipe things, and instead of 9, maybe we could make this 4. And I'm going to replace that with y. Alright, so now we have variables as well to deal with. And this is what's similar to something that you're probably going to see more often, because with Boolean expressions, we want to compare variables with numbers to provide a certain context. So x is less than 9. 6 is less than 9, so this thing will be true. 3 is greater than or equal to 4. Well, that's a false statement. So we have true here and false here. Unlike the AND operator, this entire thing becomes true because we have a true statement here, and that's really all we need. And I have to change that Boolean x is now Boolean z, and then we're going to print out Boolean z. Scared me for a second there, but I use the same identifier. That's why we don't utilize one identifier, one single letter identifier. Anyway, that returns true because this statement here, this Boolean expression here, is true. So now let's change this to greater than. So we already know that this is false because I'm not changing it. But now we have to look at this. 6 is greater than 9. 6 is not greater than 9. So this thing will be false. This is false. This is false. And since there's no true statement, this entire thing becomes false. And there you go. We have a false statement. Alright, before I get into I'm going to make these comments so that I can go back to it. But the not operator is pretty simple to understand. Basically, if it returns true, then it's false. If we have a false statement, then it returns true. So let's say we have a Boolean a, and we set that equal to true. Now, to turn this into from true to false, we just simply put the exclamation mark there. So when we put system.out.println, and then we ask to print out a, it's going to print out false. And it prints out false because it says sees a true statement and has a not operator. So it converts the true statement into false, and false gets assigned there. Now if we change this to false, it becomes true because it sees the false statement, but then it sees the not operator. So it converts false into true, and then it goes into Boolean a. And when Boolean a gets accessed, it becomes true. Now I want to use the non-operator on the previous section. So I'm going to go back to these variables and print statement. So what does this compile? This compiles into false. So if we want to convert it to true, we put the exclamation point there. We could put it also here or here. And we get true, even though this was initially false in our prior testing. See over there, false. Now it's true. So if we change this to that, now we have a true statement, and now we have a true statement. So, we have a true statement, and we have a false statement. So as long as one of them is true, the entire thing becomes true. So we run it, and now we to convert that into false, we put the exclamation point there. Now we can experiment with this by putting an exclamation point somewhere else as well. So let's say if I go back here and print out this, it produces a false statement, but only one of these has to be true. So what we can do is we can put the exclamation point here, so one of them actually does become true, and then the other one becomes false. And it becomes true because we have that one true statement here. So it's something that you have to experiment for yourself, but the exclamation point, the not operator, allows us to convert Boolean expressions such as these or other Boolean expressions into the opposite of what they are. And that wraps up our video on logical operators. I hope you enjoyed it.